What they are learning, your 3 and 4 and 5-year-old friends, are learning the grammar, the structure of language, like what language is, which is actually totally different than learning a new language, a second language. The window of plasticity for being able to sonically morph into a language, that closes by about 13, by puberty. What's interesting is if you later learn a second language, that ends up in essentially a mirror image part on the right side of the brain. I think the best thing to do is to take advantage of this and understand what temptations you face and set things up in advance so you can't do the wrong thing. So Ulysses of sound mind lashed himself to the mast so that the future Ulysses couldn't do the wrong thing.
Between listening to Inner Cosmos and preparing for this interview, It is absolutely remarkable how obsessed you are with the brain and the human mind. And I was just wondering if there was an event that started this off or just something about the brain or the mind that's had you devote your entire career to it.
Well, my father was a psychiatrist and my mother was a biology teacher. So it was sort of natural I ended up here. But I didn't think I was going to because growing up, I loved literature. And so that's what I studied a lot of. Later in life, I realized they're all trying to get at the same thing. They're just ways of trying to understand our situation and get at the truth. But later I became a neuroscientist, which was a natural enough place for me to go. In college, I took a lot of philosophy classes, and I enjoyed the classes a lot, but I felt like many of them were getting into sort of a philosophical puzzle, and then at the end, you're not sure, okay, it could be that, it could be that. And I really started wondering if there was a way to complete the puzzle, to say, hey, you know what, if we actually got into the brain and did some things and understood the perceptual machinery by which we view the world, maybe that's not a problem anymore. We can get somewhere that way. So that was the other thing that attracted me to neuroscience.
So answering these really big questions about something like consciousness that philosophers have been tackling for a very long time, you thought that going through neuroscience might be a better way, or at least a supplemental way, working with philosophy to answer those sorts of questions.
Yes, but a question like consciousness is still a very tough question. I don't think neuroscience has added anything to that yet.
Interesting.
But there are lots of smaller questions. For example, there are lots of questions about the senses, like Molyneux's question about if a child is born with no inputs, would he have any thoughts, things like that. But I'll give you a specific example of a philosophical question I read and then was able to answer, which is Immanuel Kant had asked this question about three-dimensional space. If you're born blind, do you have a representation of three-dimensional space the way that a sighted person would? So we did experiments where we put essentially a vest on blind people. People were born blind, and they could feel the location of everyone in the room. So if you're over there, they're feeling it on their skin, and if you walk over there, they feel you move across their skin and so on. And the interesting thing is there was zero learning curve. People got it immediately. They just immediately got what was going on. And in fact, it was slightly better than normal vision because they could tell when someone was walking around behind them and they could feel what was going on. So we were doing these games with, like, use the force loop, because they could tell where everybody was. It was kind of amazing. Anyway, for me, that was a very small question, but it answered it of, okay, you can be born blind and we can feed in a representation of three-dimensional space any way we want, through the skin in this case, and they get it immediately.
Am I right? This is just the sense that I get, especially from the way that you pull that answer out of your proverbial top hat, that you're kind of a jack of all trades when it comes to neuroscience. It's not that you have one specific topic you've been drilling down on forever. You're just drawing from all these areas.
I guess I'd say that's right. I'm interested in how all the pieces and parts come together to construct our reality. And so what that requires is sort of being able to, go and talk to any lab on any topic. So I guess I would say, that's a nice compliment. And I guess that's always been my interest, is how does the brain construct reality? I've also been interested in how different brains do so differently, because that's a really good inroad into that question. So for example, things like synesthesia or hyperthymesia or, aphantasia, we can go into these things, but any of these situations where we see, hey, wow, people are really on a spectrum in terms of how they're seeing the world, how they perceive reality. And then finally, I would say my other interest is in how this cashes out for society, like why it matters. So I run a national nonprofit called the Center for Science and Law, which is about the intersection of neuroscience and the legal system. And that's just been a very important topic to me, possibly also because my father was specifically a forensic psychiatrist, so he dealt with the criminal justice system a lot. And, you know, what was absolutely clear to me as a child, because he taught me this, was that people can be really different on the inside. People's construction of reality, their decision-making, what drives them, they can be really different on the inside. And so as a society, we needed to figure out what to do in terms of that.
I've listened to a number of episodes of Inner Cosmos, and I have plenty of questions about this sort of grab bag of topics that you cover. One thing that you've mentioned already that I really want to get back to is the contention that neuroscience hasn't really answered what consciousness is yet. But first, what I want to ask about is something that has been on my mind, but that I don't think you've mentioned yet, which is brain plasticity. And the reason in particular that I'm thinking about, it's very topical for my life right now. I recently decided that I want to be a dark chocolate person and a coffee person. And these are things that I really don't like. But I have been forcing myself to consume coffee every morning, to consume dark chocolate every day. And just recently, actually, as I was on my way to another neuroscientist's office at Princeton, Michael Graziano, I found myself drinking a nitro cold brew and relishing it and like wanting the next sip. And what I found so surprising about this was I really don't like the taste of coffee, but I was still really coming to enjoy it. And I wanted to ask what it is that's happening in my brain in particular right now as I'm going through this coffee and dark chocolate arc.
I mean, one of the big things that's going on is that your brain is always trying to figure out how to credit things in the future with what you did in the past. So if you drink something and some minutes from now, you're feeling more energized and alert and so on, your brain does this credit attribution and tries to figure out what the heck were you just doing some minutes ago. But I think this is a big part of what's going on with coffee addiction. I have my coffee cup with me here. And yeah, I was actually wondering about this the other day. Many cups of coffee that I get don't taste that good. I was in the bank the other day and they were giving out free cups of coffee and it was super terrible. And yet I drank it because I'm addicted to something else about it, not just the taste, it's the consequence.
What is happening, though, maybe at a neural level when my brain is undergoing these changes? Maybe you need a specific experiment or something involving coffee to answer that.
Well, it's pretty straightforward to answer because this is generally what brains are built for, is figure out what is rewarding in the world and how to strengthen those connections such that you seek that. There have been a million animal experiments on this for many decades. But yeah, you have these systems in the brain. This is all about brain plasticity, as you introed this with. You know, the system is trying to figure out what are the things that are giving me something that I need, whether that's sugar or energy or whatever it is, or pleasure in some way. And then it strengthens the connections for those things. So you notice them more. You seek that your behavior is changed. So you seek those things more.
I guess abstracting now from the particular situation to the general, is there a point at which brain plasticity peaks in our development and then a time when it reaches a trough or it's just steadily declining?
The answer generally is that it declines with age. It does not ever hit zero. I mean, at the age of 90, you can learn a new person's face or a new movie star, or you can start learning a new language, things like that. A big part of plasticity, this was my last book called Livewired. Big part of plasticity has to do with relevance and motivation. You've got these neurotransmitter systems that are all about what is relevant to me. And so the part of the reason that learning a language is harder as you get older, I'm a lot older than you are, it's hard for me to learn, is because I don't have quite sufficient motivation for it. You know, I really want to, but it's not the same as dropping myself into a country when I'm 20 years old and having to do it, or you know, getting some girlfriend and it's, you know, it's like a relationship issue that I need to be able to communicate at the age of 20 or so. It's a totally different situation when you're my age, you've got 100 other pulls on your time. So that's a big part of what's going on with brain plasticity. But in answer to your question, at the age of 2, is when you get the most synaptic connections. So you get all, 86 billion neurons. That's all you're ever going to have. You don't make new neurons, with a tiny possible exception of what's called neurogenesis, but that's very debated in humans whether it happens. And even if it does happen, it's probably not much. So you got your neurons that you drop into the world with. Those are forming connections with each other. And what happens is in the first 2 years of life, they're making incredibly dense connections. They're connecting. It becomes like an overgrown garden. And from the age of 2 onward, the whole game is about pruning. It's about reducing those connections. So you go from, let's say, 20,000 connections per cell down to about 10,000 as you get older. And so a big part of plasticity and learning the world that you happen to have dropped into is about getting rid of things rather than making connections. The other thing I should mention here is that different brain areas have different windows at which they close. So for example, your visual system drops in the world, realizes, okay, there's edges, there's orientations of lines, there's angles, there's color. Okay, that's it. And so your primary visual system crunches down and essentially locks into place pretty early on. In contrast, your what's called your somatosensory system, which is, understanding your body, and your motor system, which is driving your body, those are plastic your whole life, which is why at any age you can learn how to use a pogo stick or a hang glider or some new device, hoverboard, because your system, the argument I made in the book is that I suspect that this is because of the stability of the incoming data. In the visual system, everything stays as it is, and as a result, your system says, okay, I'm going to lock down. But in the case of your motor and somatosensory system, they say, whoa, look, you're getting a little fatter, a little thinner, a little more muscly, a little less muscle. You broke your ankle, whatever. And so it stays flexible because you're always changing.
This is maybe a naive question, but is learning just a particular instance of brain plasticity?
Yes, that's exactly right.
Okay, and you mentioned that in Livewire, relevance is emphasized as one of the crucial components of brain plasticity. And one of the things I'm wondering, because unfortunately I have not read Livewire, but I'm sure a lot of people would be interested in this, are there recommendations for how to increase brain plasticity and to improve learning outcomes?
Yeah. The main trick that I tell all my students here at Stanford is you actually have to figure out why something is relevant to you in that moment. So let's say you're studying for the big test tomorrow. You just have to figure it out. Like, okay, look, why am I actually doing this? Maybe I hate this class. Maybe I'm not into this right now. But I really want to go to medical school, or I really want to impress my mother, or I really want to impress that person across the hallway, or whatever. Like, you figure out what it is that drives you in that moment, and you hang on to that, and that's what gets the acetylcholine going, which is telling you about relevance in the brain, and it's causing changes to happen. The interesting part is there's a whole collection of experiments showing that if you do some action over and over again, you can see these big brain changes. But if there's no motivation and you do the exact same thing over and over and over, no brain changes. In other words, the relevance has to be there. Now, what does relevance mean? It actually equates to a cocktail of neurotransmitters that are present in the brain, the main one being acetylcholine. And you need that there in order to say, okay, look, something should change. Because, look, the truth is that most things in our life, we take in so much sensory data and it's irrelevant. So you don't want to change based on the number of cracks in the sidewalk or what shirt somebody was wearing or the car that was stuck in front of you at the traffic light. It just doesn't matter. But what you want to do is learn, okay, these are the things that matter to my life, and I'm going to mold my brain around those.
Something else that you said that stuck out at me is learning new languages, and how learning a new language because of a loved one might make it easier to learn because of this increased relevance. I was dating a Hungarian for a while and picked up Hungarian pretty quickly. I was not fluent, but I was fairly conversational. But I've also, in the past couple of weeks, started learning Japanese, just because, one, I'm going to Japan in a month or so, but also it has always been on my list of languages. And I'm finding that even though it's a very different language, the novelty of having to learn this new writing system, The sounds aren't that new if you know Spanish, but it's making it a lot easier than relatively simpler languages to learn.
Yeah, exactly right. You found some way. And if you go there and end up in a relationship, you probably learn a lot faster. Yeah.
Yeah, probably. I imagine, though, that a lot of that is just having more opportunities to practice.
Yeah.
But this is folk wisdom, and I'm not sure if it's true. I have a hunch that it's very not true, but that children, particularly toddlers, learn languages faster and better than adults. Do you think that this is true?
I think that is true.
Okay, please.
And I think that's probably because there's nothing but plasticity at that age, but also it is massively relevant for them. They want so badly to communicate and they start getting the picture after some number of months that there's certain things, if they point or if they do what, they start realizing that you can communicate with the world and get things that you need. And of course, at the beginning, it's just crying and screaming like I'm in pain or I'm hungry. But they start realizing that they can actually command the world if they can just control this way of their larynx and the respiration in and out and shaping their mouth the right way. And so they learn that as the most relevant thing in the world for them. What's interesting is even if a baby is born deaf, they will babble with their hands. I mean, assuming they have sign language exposed to them and they see their parents doing sign language, they'll start doing that and making motions with their hands because they are trying really hard to figure out, how do I make this so that someone does what I want them to do?
The reason that I would want to push back against this is I have spoken with 3-year-olds, 4-year-olds, 5-year-olds, 6-year-olds.
So my best friends.
And I am remarkably unimpressed relative to adults with their linguistic abilities. Surely in 2, 3, 4 years, I don't think that I could develop a perfect Chinese accent, for instance. But I think that in 4 years of devoted study, I could speak Chinese better than a 6-year-old.
Great. So this opens up a really important point, which is that there's all these different aspects of language and they have different plasticity windows. So what they are learning, your 3 and 4 and 5-year-old friends, are learning the grammar, the structure of language, like what language is, which is actually totally different than learning a new language, a second language. Because what they're learning is, nouns refer to objects out there and verbs are action and I can modify things with adjectives. Like they're learning the knowledge of what this is. Here's the way to think about this. There are different ages where your plasticity language closes. So if you are not exposed to language within, let's say, the first 6 years, you're never going to learn language. You can't get language. You don't get grammar, structure, now you just don't get any of it. You can't speak language. Okay, if you were exposed to language, as you were, then you can learn a language later. But if you learned Hungarian, let's say, after the age of 13, you're going to have an accent no matter what. If you learned Hungarian before you were 13, you wouldn't have an accent because the window of plasticity for being able to sonically morph into a language, that closes by about 13, by puberty. There are all kinds of interesting, I'll just mention one last piece on this, which is your first language ends up getting, all the machinery is taking place in the left side of your brain for almost everybody, in the temporal lobe here. What's interesting is if you later learn a second language, that ends up in essentially a mirror image part on the right side of the brain. And we've known that for a long time, even well before brain imaging, because sometimes what will happen is somebody will get a stroke that knocks out this left part of their brain here, the left temporal lobe, and they lose the ability to speak language. But through a lot of practice and so on, they learn how to speak a language again. And then they are unlucky enough to get a stroke here on the right side, and then they lose their language again. So anyway, we know that these things can move around, and the first language and the second language can be stored in different places, things like this. But yeah, I just want to point out that when you're learning your first language, it's more than just, this table is mesa and so on. Instead, it's a much bigger thing of understanding what language is.
I find this topic incredibly interesting, brain plasticity, but I want to make sure that we can cover some of the other things you've researched on. I have one last question, though, and that is for me and for other people, perhaps, who want to change their dietary habits. Is there anything other than relevance? So, in other words, figuring out what's motivating you to do this that can help grease the brain plasticity in this regard?
Yeah. Well, in my opinion, that particular thing, which we all do, we all, try to modify our behavior in the right ways. The best thing to do there is to understand that you are actually not one thing, but you're made up of all these different neural networks that all have their own drives. You may know that I've written about this in my book Incognito. I call this team of rivals, which is all these neural networks running under the hood that all have different desires. They all care about you as much as that's a possibility, but they all have different ways of going about it. So, for example, if I put some, slice of pizza in front of you, part of your brain wants to eat it. Part of your brain says, no, I'm trying to be in really good shape and I don't want all these carbs. I'm not going to eat it. And you can argue with yourself. You can get mad at yourself. You can contract with yourself. It's very interesting that we typically don't recognize this about ourselves until it's pointed out, is that you're not one thing. Okay, so I think the best thing to do is to take advantage of this and understand what temptations you face and set things up in advance so you can't do the wrong thing. This is called a Ulysses contract. And
Sirens?
Yeah, exactly. So Ulysses of sound mind lashed himself to the mast so that the future Ulysses couldn't do the wrong thing. And that's probably the most powerful thing that I know to make sure that you do the right thing. So if you're trying to change your dietary habits, just make sure that in your cabinets, in your fridge, or whatever, you don't keep something you think, oh, I'll be good when the moment comes, because you won't be in the, midnight on a festive Friday night or something. You're going to go ahead and eat it. So just make sure you don't keep it in your house.
Moving on, but still staying relatively close to some of the things that we've discussed. This is actually, I think, going to come out immediately after this episode I did with Michael Graziano at Princeton. And I wanted to cover a few of the same topics just to hear a different opinion.
Great.
And something that we talked about a little bit was Helen Keller. And I find that relevant since we've just been discussing language. And one of the things that I was curious about was there is this famous passage from her autobiography in which she claimed, maybe you know the one that I'm talking about, but I'll say it anyway, where she does not believe that she was conscious before she learned language. She described herself as sort of bumbling around, motivated, maybe like an animal in a certain way, but then learning language just made her a person and gave her a self, and that's when she felt that she was conscious. And I'm wondering if this makes any sense to you. The reason that it would just facially is, I think in his philosophical writing, Daniel Dennett argues that language is vital to consciousness and how we structure the world around us.
Certainly some people believe that. How old was she when she learned language, Tina?
I don't know, and that's why when you said that somebody can't learn language after they're 5 or 6 or something like that.
Exactly.
I was interested.
That's why I just want to, I don't know this quotation, but I would need to know how old she was.
I should just add really quickly, I find this funny. I'd learned that there's a conspiracy theory that Helen Keller never learned language, and all of this was made up by her helper.
Oh, God.
I doubt that's true, but I found it amusing.
I would need to know what age she learned, because she had to have learned it by the age of 6, or else she wouldn't get what language is about. And certainly she was very articulate, or her helper was. And so if she, let's imagine, learned it at 5 and is thinking back on her 2s and 3s, and of course you're not, think about yourself at the age of 2 or 3 or 4. Did you feel like you were conscious? Hard to say, but you certainly didn't even lay down any memories till you were about 3.5. So I wonder if that's what's getting conflated there.
You said earlier that you don't think that neuroscientists, I don't know if you said, these weren't your words, but that they haven't cracked consciousness, or that they just haven't made a lot of progress on it. So maybe I'll let you elaborate on that.
I would say they haven't cracked it, right. There's plenty of progress in the sense of really laying out the field. Like, it could be this, it could be this, it could be this. It's a terrifically fascinating area, and really the one most central to our lives. So I'm in no way denigrating the pursuit, but we haven't cracked it. We don't know the answer to it. And of course, the way we would know it is if we could actually build something that we're conscious. The difficulty there, of course, is we don't know when we've built it. If we've just built a good, a statistical parrot like ChatGPT that says, yes, I am conscious, and it's not. But in any case, we don't have any theoretical reason, any equations we can walk through and say, oh yeah, I get it. That is what consciousness is. We're totally stuck at the beginning, I would say.
Well, maybe to get a landscape, so to speak, on the table, are you open to non-physical theories of consciousness? Are you open to theories like dualism or panpsychism, or just theories that there's a God and we have souls and that's how we're conscious? Or are you more of a materialist, very scientifically oriented when it comes to these questions?
I am very scientifically oriented, but what that means is having a broad table so that you can accept hypotheses. There's no point in ruling out hypotheses prematurely. So I would never say I'm a materialist or I'm a panpsychist or so on, because what I am is a scientist trying to understand this question. And so it actually drives me crazy when people in science take strong sides on things that they can't possibly know for sure is the right side. Now, I'm all for the advocacy system. That's how we structure our legal system here in the U.S., where you have someone playing prosecutor, someone playing defender, and that's really useful because this person tries as hard as he can to prosecute, this person tries as hard as he can to figure out ways to defend the criminal and so on. But in science, I don't know if that's as useful to pretend certainty when you just don't have it. So when it comes to a big open question like consciousness, my interest is to deeply understand all the different hypotheses and figure out, obviously, the game for all this is, okay, what experiment could you do that would at least divide these hypotheses, even if it's not the complete answer, to at least put these guys off the table and put maybe some new guys on the table that we hadn't even thought of yet, that sort of thing.
Okay, well, given this, are there any theories that at this point, or hypotheses that you find most promising for explaining what consciousness is?
I don't think so, but I do gravitate personally to those theories that could be tested and built. So let's call this the materialist camp generally. I'm not saying I am a materialist, but I'm most interested in seeing if we can rule those in or out first. Why? Because we can do something about that. We can actually say, okay, look, let's say it is just a bunch of pieces and parts organized in the right way, running the right algorithms. Well, that gives us a handhold where we can say, great, we should be able to replicate this then and do it and figure it out. So I happen to be personally attracted to those because there's something to be done, as opposed to whole classes of other theories, which might be right, not criticizing them, but there's sort of less that I can do about it. So at minimum, if I devote my life towards the physical theories, I can at least hope to rule something in or out.
Have you done any experiments on these theories or research into this yourself?
That's interesting. I mean, a lot of what I do, I mentioned earlier that a lot of what I do has to do with understanding how consciousness is different for different people. And so one example, synesthesia. So some people have a blending of the senses. So maybe they look at letters and it triggers a color experience, or they hear music and it puts taste in their mouth, or they taste something and puts a feeling on their fingertips, things like that. Their senses are mixed more. It's not a disease or a disorder. It's just an alternative way of consciously perceiving the world. So we can look for what the physical differences are, which are like, a mutation in a gene, just a little tiny thing here, and then you're perceiving differently than I am. That's actually another example of something that used to be, in my mind, for me personally, it was a philosophical conundrum, which is, okay, is it possible that I see red differently than you see red? And so on. That felt to me, when I was learning about those in classes, like a cool question, and I couldn't figure out how to answer it. But now I've studied, 64,000 synesthetes. I've put together the world's largest database of synesthetes, we've done brain imaging, all this stuff. And now we can really get somewhere on this question. Okay, look, we know these people are perceiving something differently than these people. So what is the difference physically, genetically, and how that maps on their consciousness? So that's the kind of thing that I'm doing on that point.
Let's digress from consciousness for a little bit and then come back to it because I want to hear more about the synesthesia. So it seems like you are one of the leading researchers on synesthesia. You've probably spent more time with synesthetes than most people. What are some of the most fascinating cases of synesthesia that you've come across? Or what are some of the experiments that you've run on synesthetes to prove that they're not just making things up about synesthesia?
Yeah, exactly. Well, what I did way back in 2007 was I said, I mean, now it's trivial, but at the time it was the first of its kind thing of, instead of bringing synesthetes into the lab by posting with flyers and having them come in and testing them that way, I made an online synesthesia battery that's uncheatable. And that's what blew things up from having a few synesthetes. Everybody who had papers on synesthesia just had like an N of 4 to, now we're dealing with tens of thousands. But the test essentially is, let's say you have letters to colors synesthesia. So I present on the screen a letter, and I give you a color palette with which you can choose any of 16 million different colors displayable on a computer monitor. And you find exactly the color that's generated with that letter, and then you press submit, you see the next letter at random. So what happens is you see all the letters and numbers 3 times each in random order. And each time you're picking a color. Well, it turns out if you're a synesthete, it's trivially easy for you to, pick the same color each time for the letter J and then the letter T and so on. But with if you're not a synesthete, I ask people, okay, use a free memory, use your memory, use free association, use whatever you want to try to remember what you did. So people are terrible at it because it's really hard out of 60 million colors to remember what you called, M 57 trials ago out of all these colors. So anyway, it's a way that I can very sensibly discriminate real synesthetes from malingerers. So that's helped a lot just in terms of knowing, as you said, who is telling the truth about it. And then we do brain imaging experiments. We've been doing genetics on this for a long time, actually. We haven't quite found the gene yet. We found a hot spot on chromosome 16. What's interesting about this, I just want to mention that when you're doing genetics and you're looking for a question about someone's conscious experience, they're so distant, these issues, that no matter what gene I find here, we're all going to scratch our heads and say, what? I mean, it's going to be some protein has a slightly different amino acid here, and that spins all the way up to a completely different experience of the world. That's weird.
Well, I have a number of questions about the synesthetes. I think the first question that comes to mind is, so you used the letter J, for example. When a synesthete associates J with a specific color, is it the case that when they see a J on the page in black ink, they see it as green, or does their whole visual experience just have like a green color filter on it? Just what is changing about their experience of the world as a consequence of observing the J? Yeah.
What's interesting is they know that it's in black ink. They can see it's black ink, but to them it's self-evidently true that J is green. And so for example, if I asked you to picture a pumpkin sitting here, and I say, what color is it? You'd say orange. But I'd say, well, are you hallucinating orange? You're not you're not thinking the whole world's orange, but it's like obvious to you that thing you're imagining is orange. And that's exactly what it is for a synesthete. And there's all these different forms of synesthesia, but it's essentially the same thing in all of them. It's not a hallucination, but just those things are the same thing. J and green to them is one thing. Yeah.
This is only a family resemblance of examples, but I read Dennett's Consciousness Explained in high school, and I believe he has this example. He says, picture a purple cow. You've done it. Now, where is the purple cow? Because there is no purple cow in your brain, but you're still having this experience of a purple cow. When the synesthete sees the J, they're associating it with green. What is happening in their brain that is giving them this green experience that is not connected to something that is actually green in the world?
Yeah. You've got areas that are involved in color perception in your visual system. So when you picture the orange pumpkin, you're tickling those cells. There's a much deeper story behind this, which I'll just mention in a sense. We could drill in more if you want. But, if you look at the visual cortex, only 5% of the input to the visual cortex is coming from the eyes. All the rest is feedback connections. Yeah, all the rest is feedback connections. So most of vision is about internal activity that is merely modulated by a little bit of data that's dribbling in through these spheres in your skull. That's it. So So it's no surprise that we can imagine orange or green or things like that, because most of it's all feedback in any case. So it turns out that this thing about letters and colors is one of the most common forms of synesthesia. And it turns out that the brain areas involved in letters and the brain areas involved in colors sit right next to each other. And so presumably what we all think is the case is that there's just more crosstalk. There's just a little bit more of a porous border there between those two areas, letters and colors, that are just talking to each other a little bit more. It's like a country with, with porous immigration borders. There's just more activity going. Yeah.
Is synesthesia ever debilitating for people, or is it just novel and interesting for neuroscientists?
It's the latter. It's just novel and interesting for neuroscientists. What's very interesting is a lot of people assume that people with synesthesia have a more creative life or something. But in fact, if every time you look at J, you think green, that's not creativity, that you're stuck in that rut. It's just an alternative perceptual reality. That's the weird part about it. And so for people with synesthesia, I mean, the crazy part is that even as recently as when I give talks on this, maybe 15 years ago, and I would talk about this to an audience and ask who's ever heard of synesthesia. Most people have not even heard the term 15 or 20 years ago. Now it's somehow leaked into public consciousness, which is wonderful. But the point is, people with synesthesia would sometimes sit in the audience and they'd be so surprised by learning that, wait a minute, 97% of the people in the audience don't experience what I'm experiencing. Why? Because we all assume that everyone experiences reality exactly the way that we do. And so, that's just their reality. And they were surprised to learn that there was this label and that other people didn't have it that way.
Perfect excuse for me to transition into what I wanted to talk about next, which is getting back to consciousness, but more particularly with regard to animal minds. The reason that I find this interesting right now is another dietary arc of mine is I am concerned, at least in a way that is spurring me to act on my concerns for animal well-being that I didn't have before. And for me, the first consideration in thinking about this is, are animals conscious? What does it mean for an animal to be conscious? And are they capable of suffering? And maybe the first thing I ought to ask you is, do you at all find that science should be helpful in questions that are conventionally moral in this case? Because Michael Graziano, for instance, didn't feel this way. He thought science would be of no help here, that if it makes you feel bad to eat shrimp or something, you just shouldn't eat them. Whereas for me, I think I feel bad about it because I believe that they're conscious, and if I have a good reason to believe that they're not conscious, then I don't have a good reason to feel bad. So that's what I'm curious about.
So I agree with your intuition. Morality should, of course, be built on top of science to the degree possible. Now, the caveat there is that science is often wrong. The counter caveat is that science is really the only field we have that constantly knocks down its own walls. So this is to say, we should build morality on top of science. We shouldn't take science too seriously at any moment in time. But as the weight of the evidence accumulates, then I think it makes perfect sense to build on top of that. Now, that said, we don't know what it's like to be an animal. We just don't know. If I had a guess, obviously people used to think, I don't know, it's interesting to me just that everyone used to sort of think, oh, humans are conscious and animals are not. I think nowadays everyone thinks it's more of a gradient, which would make more sense. I mean, animal brains and our brains are so similar. It's quite striking if you look at dog brains or squirrel brains or horse brains or whatever. It's all the same stuff. You got, hippocampus and cerebellum and thalamus. It's all the same stuff. We just have slight differences. We've got much more cortex, the wrinkly outer bit. We have a much bigger prefrontal cortex, but certainly all the basic stuff that allows for suffering, you got in the other animals too. So I don't see any reason why there'd be any reason to say that they don't suffer. Actually, what's interesting is I'm kind of seeing Graziano's point here, which is that if that's all we have, that maybe they suffer, one could still make one's own decisions about, well, look, the way the cow is killed is they have a pretty nice life eating grass on the hillside, and then suddenly their throat is slit and they don't know it. maybe somebody could make the argument that it's not really suffering, and therefore they still want to eat the meat.
Well, let me ask you this. I don't want to make assumptions about your dietary practices, but assuming that you were of a mindset like mine, where you don't want to eat animals if they are suffering, I would think we can agree that plants aren't suffering based on our knowledge of neuroscience and what it means to feel pain and suffer. So you'd probably be okay with eating plants. But then we would get to something quite rudimentary in the animal kingdom, like bivalves, so scallops, clams, this sort of thing. How would you approach the question of asking whether or not this animal is capable of suffering and whether or not you should eat it if you don't want to eat things that can suffer?
Yeah, I mean, if we're talking about a gradient, then what you're asking is, where do you draw the line in the sand on a gradient? And that's an impossible question to answer. The legal system's always coming up across these kinds of questions of, here's a smooth continuum. Just as an example, the development of the brain, there's no difference between someone who's 18 years old in one day versus someone who's 17 years old in 364 days. But one of them you can execute, one you can't, according to the Supreme Court. Does it make sense? No, but the legal system needs bright lines. What you're asking me is a bright line question of where would I draw the line, and I can't answer that with animals.
Do you think that there are, clues from research on human consciousness that could help us with this question? For instance, maybe we know from the NCC program that if you damage some part of the human brain, humans don't have conscious experience. Then you look at a scallop and you say, oh, it doesn't even have a brain, or this part of the brain for that matter. So
good question, but all the basic stuff about the limbic system and pain and reflex and whatever, we got that across the animal kingdom. You have, even in very, very simple organisms, ways of saying, oh, something noxious happened and I'm going to withdraw my gill and whatever. That's essentially the most basic machinery that you come with to the table as an animal to survive. So therefore, that makes it tough. And by the way, the reason I would hesitate to do that anyway, to take human consciousness as any sort of version of this, is because you can, look at humans. Let's say you say, okay, look, humans are intelligent, so we're not going to eat other intelligent animals. But what do you do when you have a child with Down syndrome? Do you say, okay, well, look, he's got a really low IQ, and so if we can eat, a cow, then we can eat this kid or something. I mean, I think using human intelligence as the metric is a dangerous place to go on that. Yeah.
Well, maybe now's a good time to transition into intelligence. Right. You used the qualifier human intelligence, which presupposes maybe there's something more generally about intelligence. How do you think of intelligence more generally so that it can apply to things possibly like machines or animals or humans, though we are animals?
So I'll answer this in a few ways, including something that I've been chewing on a lot lately. Okay, so first of all, I have this nice backyard and I watch the squirrels jumping around from tree branch to tree branch. It's completely insanely amazing what they're doing. They're doing something that is better than our best gymnast could ever do, and they do it effortlessly. Is that intelligence? Sure. It's a very different kind of thing. Now, their intelligence is not looking at F equals ma. They're not thinking about, okay, the trajectory and I've calculated this out. They're just somehow doing it because that's what they're really engineered and good at doing. So here's what this got me thinking about lately. Have you seen these videos from Sora, which is a text-to-video generator?
I have not.
It's absolutely amazing. So, okay, so Dolly or Midjourney or somebody, you type in something and it generates a picture. So this does video. So you type in, show me the surf hitting a cliff with a drone shot. And you see this video, like footage from a drone of the ocean waves hitting a cliff, and it is picture perfect. I mean, it's extraordinary. Wow. So here's the thing. I stared at this video, which is totally AI generated, and the waves look perfect. I mean, the waves do exactly what waves do, and the white caps and the crashing and so on, and the way they throw themselves over the rocks and so on. But Sora is not, there's no physics engine in there. It's not reproducing anything about physics. It simply has watched gajillions of videos, and it has these notions of how things continue through space-time, and that's it. And somehow it reproduces these waves essentially perfectly. So what that got me really chewing on, I don't know I haven't come to a conclusion on this yet, but my question is, what if we had invented Sora, this text-to-video generation, before Isaac Newton came along, before we had F equals ma, d equals 1/2 at squared, all this way of looking at physics that we humans do? What if instead we had done it the way that squirrels look at physics, where they're just somehow they've got intelligence about physics, but they're not, making it into equations? My hypothesis is that we'd have a very different kind of world. We'd still be able to do incredible things. We'd be simulating things like, okay, we're going to run this simulation for how to get to the moon, but we don't know exactly. It's not paper and pencil equations, but nonetheless, it would probably work and we'd be able to get there. So this has got me thinking a lot lately about what do we mean by intelligence. There's certainly different ways of casting things. The one we're used to is, okay, yeah, you come up with an equation, you write it down in a book, but maybe there are very different ways that we can get places.
You said earlier with regard to consciousness that we might create a machine and then not know whether it's conscious. And I'm wondering if you have a definition or a way of thinking about intelligence whereby we would know whether a machine is intelligent, like ChatGPT or Deep Blue or something like that.
Yeah, well, I'm glad you asked that, because I've just written up something called the intelligence echo illusion, which I'm fascinated by. This is the name that I'm giving to this, which is I've noticed that a lot of my very smart friends are making a very basic mistake when it comes to ChatGPT and intelligence. So what they're doing is they're saying, hey, look, I asked it some really sophisticated question. Let's say a question about theory of mind, which is, can you put yourself in someone else's shoes? So you probably know this, but just for the watching audience, you walk into a room and put your hat on the table there, then you leave the room. I come in the room, I see your hat there, I put it away in the closet, and then when you come back in the room, where do you go to look for your hat? Anyone with theory of mind can say, oh, he looks for it on the table over there because that's where he thinks it is, even though they also know that it's in the closet. Okay. The question is, can AI, current LLMs, large language models, can they do theory of mind? And the answer is, one of our colleagues here at Stanford wrote a paper saying he thinks that theory of mind has emerged in large language models. I think he's totally wrong.
Really? That surprises me.
I think he's 100% wrong, and here's why. So I've spent a lot of time typing in these questions and testing things about what ChatGPT can do. It gets these things right like 60, 70% of the time, and that's enough to convince him. I'm not convinced, and here's why. It's because what ChatGPT is actually doing, as we know, is drawing from everything that's ever been written by humans. Now, I did a quick back of the envelope on this. It turns out that if you read every day of your life, every single day of your life, from the time you learn how to read till the time you're an old man, the amount that you could read would be 1/1000th of what ChatGPT is trained on. So you'd need 1,000 lifetimes to read what it's read. And by the way, you need a perfect memory for remembering it all. Okay, so the key is, when you ask ChatGPT a question about something, you don't know whether some human somewhere in that thing that's 1,000 times more than you'll ever read has asked a question that's sufficiently similar. And that all ChatGPT is doing is echoing something that someone's already done. So you type in the question and then you think, oh my God, this thing is sentient, it's got theory of mind and so on. But what I'm calling this is an echo of the intelligence that's already in the corpus of human writing and thinking. And we mistake that echo for the voice of GPT, and we think, wow, it's just said something amazing. So I've seen this happen a lot. One of my very intelligent friends came up to me and said, look, I think ChatGPT can do visual imagery. I said, why do you think that? They said, look, I typed in this question, take the letter D, turn it on its side, then take a letter J and slide it underneath. What does that look like? And ChatGPT says, looks like an umbrella. And he said, therefore, it's actually doing visual imagery. I said, for God's sake, that is one of the oldest visual imagery questions in the literature. Steven Pinker and Martha Farah wrote a paper in 1989 using exactly that example. What if you take a D, turn on its side, you slide J underneath, looks like an umbrella. And so the thing is, my friend had somehow heard that question before. I don't know if he didn't remember where he heard it or didn't remember having heard it, but he thought it was an original question. And so he asked it ChatGPT and it gave a good answer. He thought, clearly this thing is sentient. I think this is sort of the most important thing I'm working on now, is just trying to spread the word on what I'm calling this intelligence echo illusion, which is that people are making this mistake all the time. And they think, well, if I haven't ever heard this question, or if I don't remember hearing this question, then I'm going to assume that ChatGPT is coming up with this sui generously.
My initial response when you asked whether ChatGPT has folk theory of mind was twofold. First, I would have thought that it would get this right virtually 100% of the time, just because I've read so much literature on false belief tests that I imagine, and I know that there's so much literature out there, that it would have read these papers, understand that there's lots of research on it, that it's an important area in animal psychology, autism research, all sorts of things. So it would know these things. But then my reaction was also, it just seems wrong fundamentally to think of ChatGPT as having a theory of anything.
I totally agree. All it's doing is statistics. It's just saying what is the most likely thing to come next. Given this very clever thing that's come before, and given this insane amount of data that I've taken in, that's all it's doing. And I'm shocked actually at the amount of misunderstanding in the world out there. And by the way, I'm not talking about I'm not talking about uneducated people. I'm talking about educated people. I'm talking about our colleagues who all mistake this for consciousness or theory of mind.
Well, I'm sure we both know from talking with lots of really smart people that specialize in very specific topics that this specialization might not generalize to knowledge in other areas. So, I mean, some of the world's best mathematicians might be insanely good at math, but have very funky views that aren't well thought out in other areas.
Yeah, exactly right, exactly. What is it called? Attribution error or something, which is if you're good at one thing, you think like you'll be good at the stock market. And then Isaac Newton, I just learned recently, lost most of his wealth in the stock market. He just invested poorly and kept losing money. Yeah.
One last thing about ChatGPT, this is something that I have been worried about, thinking about a lot lately. Given this intelligence echo idea, I wonder whether you think that ChatGPT or iterations of ChatGPT, without requiring some fundamental reworking of the whole LLM model, are poised to take over like mathematics or philosophy or things like that, given that you view them just as echoes and not really capable perhaps of surpassing our greatest thinkers.
Right. Great question. So I wrote a paper last year about suggesting a new test for how we would know if these networks were intelligent. So as you know, Alan Turing suggested, look, we could do the imitation game, which is if it could fool someone, you think it's a human, you can't tell the difference between that and a real human, then that means we've hit an intelligent machine. Well, we're way past that because ChatGPT is incredible at this and you could easily mistake it for a human. But does that mean it's intelligent or is it still just a statistical parrot? Okay, so then other people have suggested other tests like the Loveless test. This was back in the early 2000s. They said, what could a computer do something creative? Like you say, give me a story about a boy on Mars who meets a girl and they save a cat. Like that's trivial now. It's completely gone. Okay, that still doesn't answer, is it intelligent? And so, so without getting accused of moving the goalpost, what I'm trying to say is we need a meaningful test for whether something like ChatGPT is intelligent or just doing its, mathematics. Okay, so my proposal is scientific discovery. Scientific discovery is something that we do that is absolutely meaningful, but the important part is this. I divide it into 3 levels, and this is where I think all the juice is. Okay, so level 0 scientific discovery is you ask ChatGPT a question, and it gives you an incredibly good answer, but you didn't know that was already known somewhere else. That's an example of the intelligence echo. You just didn't know. Okay, so that's level 0. Okay, level 1 is where I think these LLMs can be super useful, which is that I ask a question like, look, I need a molecule that binds to this receptor and causes this to happen. It might be able to give me a brand new answer that is scientifically valid and nobody knew it. Why? Because it's read every damn book on the shelf and it says, oh, there's a fact over there and one over there and one over there. And to it, it's trivial to put those 3 things together and it just tells me the answer. I would never happen to read those 3 books in my lifetime. So level 1 scientific discovery is something super useful that LLMs will do. But level 2, that's where I think real intelligence is that we can define. And that's where you are doing something, let's say that Einstein did when he said, hey, what if I were riding on a photon? What would the world look like there? And this is how he developed theory of relativity. The idea is you're not just rehashing things that already exist, but level 2 scientific discovery is where you're imagining something that is new, that no one's imagined, and you're generating new predictions from it. Or Darwin looks at all the animal species and thinks, okay, what about the species that I'm not seeing? Like, what if there were lots of other things that did exist that are not here anymore? There are many ways to do this kind of new thinking about something rather than just, are these facts already extant? And so that's what I'm really interested in. And to my knowledge, what I would say right now in 2024 is that LLMs are not they haven't shown me any proof that they can do that.
There is a thesis, I believe by the name of psychologism, that can be stood in opposition to behaviorism, where a behaviorist would want to devise some sort of test, witness the Turing test, to determine whether or not something is intelligent based on behavior. But what I'm hearing from you is that you are perhaps more in favor of a psychologistic test, which is one that would be concerned not just with externally visible behavior, but internal information processing. And I'm wondering what it is you think about the human brain that makes its output worthy of being called intelligent, but not for ChatGPT.
Yeah, there's a few things. So first of all, what they have in common is that human brains take in everything in their world, everything from the moment where were you born?
Chicago.
So from your trajectory from Chicago to here, you've absorbed tons of things over many, many years, and your brain remixes those. It bends and breaks and blends them, is constantly generating new versions of things. That's what makes you creative. That's what makes you intelligent. And that's what ChatGPT does also. It just has a much broader diet than you do. So in that sense, ChatGPT can kind of do what you're doing. The difference is you are a human and you know what it is to be a human. And so first of all, when it comes to, you generate ideas as remixes of things you've taken in before, you know which things are meaningful and which aren't. ChatGPT can generate 100 images, but doesn't know which one is good and which one humans are going to like because it is not a human. Now that's the sort of deeper entry point, which is that as a human, you're doing all kinds of things that it is not like. You are doing mentalizing, like what is the other person thinking and feeling and so on. And it's not just a matter of pattern recognition. The deeper issue is we mentalize, so we're able to put ourselves in each other's shoes, and it's not just a matter of pattern recognition. It's that, if I see somebody outside suddenly patting their pockets and looking around in a panicked way, I can guess that they've lost something. It's not because I've seen lots of versions of that and then quizzed the person and found out that usually goes to, like, I can imagine myself in their shoes and what would I be thinking if I were doing it. So to our knowledge, LLMs don't do anything like that. We also simulate possible futures. We spend most of our time simulating possible futures as well as reminiscing about the past. LLMs do not do that with their current architecture. So there's lots and lots of things. We have a whole internal world. We have what's called an internal model. That's really the central job of brains, is to build an internal model of the external world. And that's how we operate. We say, okay, what would happen if I did this? I simulate it out. Okay, no. Okay, what if I did that? Oh yeah, that might work. These LLMs don't have anything like that. They don't have physical bodies. They don't have pain or pleasure. And so in that sense, they're very different from us. And what that means is they will be able to contribute all kinds of cool things for us. I think mostly what that is, though, is putting together the scattered facts from the books. When you ask the right question, it'll give you an amazingly good answer for things. But that may be it for the moment with the current architecture.
Great. I want to put a cap on this portion of our conversation now. This is our first time meeting today, but I already, before meeting, felt a deep connection to you on one level, and it's that I am also somebody who has all sorts of projects going on in their life, and you are somebody who has all sorts of projects going on, and I find that very fascinating. One of them, I could totally be wrong, but I think you're wearing it on your left wrist.
That is correct.
Okay. You co-founded or founded a company called Neuroscience.
Exactly.
And I want to ask a bit about what it is and what you're wearing.
Great. Okay, so I got very interested in my lab about 15 years ago. This idea about sensory substitution, which is the idea of, can you push information into the brain via an unusual channel? So remember, the brain is locked in silence and darkness. All it ever sees are electrical spikes coming up data cables, and that's all it has to work with. And yet it constructs everything about, sight and vision and touch and all this stuff. So I got really interested in this question that had been a little thread in the literature since 1890, actually, about, hey, could you take someone, let's say, who is blind and put in visual information, let's say, through the sense of touch? So just as an example, in 1969, there was an experiment where blind people were put in a dental chair, and there was this thing that poked them in the back, a little grid of solenoids. And so whatever the video camera was seeing, they would feel that poked into their back. And blind people got really good at being able to tell, okay, yeah, that's whatever. That's a telephone, that's a face, that's a triangle, just based on what they were feeling in their back. Now, what this demonstrates is, how weird that you come to essentially see with the skin of your back. But what it tells us is that it doesn't matter how the information gets there. There's nothing special about the eyeballs. It just happens that they capture photons, convert those to spikes, and ship that back into the brain. So anyway, there have been various experiments through the years, but it hadn't really been taken up in modern times. So what I did in my lab is build a vest with vibratory motors all over it. And we tested for deafness. For people who are deaf, if the vest captures sound and turns into patterns of vibration on the skin, exactly what your inner ear, your cochlea, is doing. Could a deaf person come to understand the world that way? The answer is yes. So we studied that, we published it. I gave a talk at TED on it. And then immediately afterwards, a bunch of venture capitalists came up and said, we'd like to fund this. And so it was a very sharp turn for me to go from being an academic, or I should say from only being an academic to being, an entrepreneur. But I decided to try that to push this out into the world. And so that's what I've done. That was 10 years ago. And we shrunk the vest down to a wristband, which is indeed what I'm wearing. This wristband has vibratory motors on it. It's got a microphone. It's got full computational capacity. Captures sound, turns into patterns on the skin. And deaf people can come to understand the world, the auditory world around them that way. We have several other things on top of this too. Like, for example, let's say you're not totally deaf, but you just have high frequency hearing loss, which is what happens to people as they get older. So it turns out that we're using cutting edge machine learning here to listen to human speech and just listen for certain high frequency parts of speech called phonemes. And then we buzz in different ways to tell you, oh, I just heard a T, I just heard an S, I heard a V, a B, and so on. And what happens is, for people with high frequency hearing loss, their ear is doing all the work at the low and middle frequencies. They just can't hear the high frequencies anymore. So this just tells them about the high frequency. It just clarifies what's going on out there. And so your brain learns how to combine those two signals. And after a few weeks, people say, oh, I'm just hearing clearly. I don't need hearing aids. I don't need things like that because I can just hear what's going on out there in the world.
I'll say why I'm laughing in a moment. What I'm wondering is whether or not there's enough density of nerves on the wrist. And I was thinking it would be very funny if you had this on your tongue or somewhere or your palm somewhere where there's a lot more nerve endings.
Yeah, great question. Well, it turns out that this is what I learned from stepping one foot in the entrepreneurial world. That's a matter of product market fit. So it turns out putting something like this on the tongue, great idea in terms of nerve density, terrible idea in terms of eating or speaking. So people don't want that. There's all kinds of things you can do on the face. People don't want that. We also were looking into making a glove. People who are deaf don't want to wear a glove around. But a wristband, it turns out, is great. And the answer is your brain doesn't devote that much real estate towards your wrist until it's informationally relevant, like we talked about at the beginning. So what happens is you get better and better. We've published on this data. You get better and better at distinguishing patterns on the wrist because your brain says, whoa, wait, actually, there's really relevant information coming from there. So it gives more real estate to the wrist. In answer to your question, we have 4 motors along here, but what we're using is what's called a haptic illusion, haptic meaning touch. So if I stimulate 2 of those motors next to each other, you will feel a single virtual point in the middle. It'll feel to you like a single point. And as I change the amplitude of those 2 motors, I can move that point around. And so we're actually stimulating 128 virtual points along the skin there. And as I said, you get better and better at being able to discriminate where the thing is with time.
I would just like to clarify for our listeners that this isn't product placement. You didn't ask me to talk about this. I'm genuinely curious about this thing on your wrist. And the next thing that I'm curious about is you are obviously a hearing individual, unless you've been tricking me this whole time and you're using the wristband. But what I'm wondering is, given that you have access to your ears, this feedback on your wrist is going to be very redundant. So I'm wondering why it is that you're wearing it while we're talking.
I wear it just to show other people, to demonstrate it to other people.
Because, perfect.
Right, because you hit it on the head, which is that if your brain gets a redundant information source, it doesn't care. It doesn't learn on that. So what but for somebody who is deaf, suddenly they realize, wait a minute, this person is speaking. I see the mouth moving, and I'm feeling this buzzing here. And then I see this thing drop, and I see the dog bark, and I see someone knock on the door, and I'm feeling this thing. Their brain learns up on that really fast because it's relevant.
Okay. Another project that I wanted to ask you about is Inner Cosmos.
Yeah.
I'm wondering, so that's your podcast for our listeners who didn't pick up on that already. Why did you decide to start that? And what are you hoping to get out of it?
It's a really interesting question. I've always been a science communicator like you. I think it's because I watched Carl Sagan when I was 9 years old, and it just blew my mind. I mean, you asked me at the beginning why I became a scientist, and I mentioned my mother and father, but Carl Sagan was the other part of the triumvirate there. He made things so beautiful that I still get tears in my eyes when I watch him now. There's something about the way that science runs on a campus, I'm sure you've seen plenty of this, where people sink into jargon and acronyms, and they put walls up for no particular reason, except presumably they feel smarter for doing the act of that. But anyway, I've always loved science communication. I don't know exactly why, but so I've written a number of books, and writing a book is so hard, and yet somehow it's so rewarding. I keep doing it again and again. Anyway, when I realized, obviously, you and I are sitting in the library right now, and there's all these beautiful books around, but I think these get touched a lot less than they used to. And so podcasts are this really incredible channel for reaching a lot of people. And so that's why I started that. And it has been an incredible challenge that I gave myself, because I have a lot of jobs. So I'm running Neosensory. I have another company called Brain Check. There's another company, very tiny thing that I'm about to kick off. I'm teaching here at Stanford. I've got lots of projects. I'm writing my next couple books. And so taking on a podcast was a really stupid idea in some sense, because it's a monologue podcast, and the contract I made with iHeartMedia was do it every single week. So every single week I do a new episode. I'm on 74 now, but who's counting? And look, I'm talking to a fellow podcaster here. It's hard. It takes a lot of effort to keep doing these over and over. So it was maybe biting off just at the limit of what I can chew, but I'm very glad I did it. I'm reaching a totally different audience with it than I do through my books, simply because there's a lot less reading now than there was.
Again, I would like to make a few disclaimers. One, you didn't ask me to talk about this. I genuinely wanted to, because this is how I found out about your work. I started listening from the first episode. Another disclaimer, though, I highly recommend the show. I stopped listening to all podcasts, though, and all media, after around episode 20. I mean, that's just when it sort of connected. But I listened to the first 20 episodes and I love them. And I think that they're really terrific for somebody who wants these really poignant insights and very interesting insights about neuroscience. There are, just in the last few minutes, though, each one you answer, or sometimes there are little series, you answer some very interesting questions. And I wanted to just ask about a couple of those episodes.
Great.
One, why does the brain love conspiracy theories? Why, when I hear that Helen Keller might not have actually been able to use language, am I like, I want to hear more about that? What's going on?
Yeah. A few things. First of all, we've got this internal model of the world, and it's always seeking to understand, hey, what's my best understanding of the world out there? So when you hear something and you think, whoa, maybe there's a totally different way to get at this, that attracts our attention for sure. One of the things, so as I did an episode on this, one of the things that I really thought about and talked about was the social aspect of conspiracy theories, which is, if I cook up some conspiracy theory, then I get to be the guy to tell you that thing, and I get to be the guy at the party and say, oh, did you know, moon landing, JFK, whatever it is. And so there's this whole reward that people are getting from the attention. Maybe it's not good attention, but they get attention for doing it. Obviously, at the extreme, there's mental illness where people are just making connections. For example, people with psychoses will make connections between lots of things that are otherwise unconnected. And so those are people who might actually believe in conspiracy theories. But the part that is more interesting to me is the people who are not mentally ill, but nonetheless grab onto these things and kind of like these things. And look, the fact is, there are things in life that are interesting. Like, I have no idea about this Helen Keller thing. But let's just say that it's a possibility. Let's say that she had some brilliant helper, and so it's a possible. So for me, the test is always about probability. Specifically, how many people are involved, and what would it take for somebody to say, hey, I'm going to write a New York Times bestseller book on, how I faked the whole Helen Keller thing or whatever. And the question is, why wouldn't somebody do that? So when it comes to something like, let's say the moon landing being faked, the issue is, how many thousands of people would have had to have been involved in that? And what are the chances that there are 0 defectors who came out? So, okay, look, here it is. Here's all the paperwork and everything. So it's not that I want to dismiss them, but I do want to apply probability to them.
Another one that I wanted to ask about is, why do brains fall for magic tricks so easily?
Yeah. Oh, it's fascinating. I mean, it's because we have this spotlight of attention. So even though I think you and I are sitting in this library and I think I'm taking it all in and the colors and whatever, I only have color vision right in my central vision, and my vision drops off around here at 160 degrees. I can't see past that. And yet I feel like, everything's in color and I'm seeing everything all at once. But in fact, all I'm really seeing at high resolution is what's in the spotlight of my attention. Anyway, it turns out it's so easy to draw your attention. Magicians have all these tricks, like, if you move your hand in an arc, for example, people can't help but watch that. I don't know why that is, but
wow,
as opposed to a straight line. Anyway, it's so easy to just drag people's spotlight of attention.
Even as you move your hand in an arc, wow, what is he doing? That's very funny. That's interesting.
Exactly. Maybe it's simply because it's unexpected. It's like, if I want to get from here to here, normally I'd go in a straight line. So maybe there's something weird about it, and that's what grabs your attention.
Feels like something in my lizard brain that's just very interested in this arc.
Exactly. So, so I would say the main thing is the spotlight of attention. And then there's, we have terrible memories. And so a magician can, for example, while he's doing so, he touches the card deck and whatever. And then he says a minute later, okay, I haven't touched the cards and blah, blah, blah. And because he said that, you believe that to be true, even though you saw him touch the cards, but then that overwrites your memory. Anyway, you put together these things about attention, about memory, and so on. It's pretty easy to pull off magic tricks.
Okay, last question, and then I will release you into the world, and that is, why can't we tickle ourselves?
It's because with this internal model that I mentioned, you have also what's called an internal predictive model, which is when I put out a motor action, like I'm going to move my arm and I'm going to tickle my underarm, I predict everything that's going to happen there. I predict the sensory consequences. So I can't get tickled. But if someone else tickles me, I don't know exactly when they're moving their finger, and so I laugh. And and so it's this really goofy thing that you can't tickle yourself unless you set up something. You can build this, like, let's say you set up a lever and it has a feather on the end of it and whatever, but you have a computer inject a little delay so that you don't know when you move the lever, it's going to move the feather in your underarm, but you don't know when exactly it's going to happen. And then you can tickle yourself just fine. And by the way, people with schizophrenia can tickle themselves because they have a problem with their forward predictive model. So that's, almost a diagnostic capacity there.
David, this has been phenomenal. You have really demonstrated that you are a jack of all trades when it comes to neuroscience. It's almost like I was examining you and you just kept having answers to everything. So again, thank you so much. You just explained how busy you are. So I really appreciate your taking the time to come and talk to me today.
Great. It's such a pleasure. Thanks for having me here.